Welcome to Excel 2010 Business Math video number 80. Hey, if you want to download this workbook, Excel 2010 Business Math Chapter 10, click on the link below the video. Hey, we're going to start on the sheet compound versus simple. And in this video, we're going to talk about the difference between compound and simple interest. Now, last chapter, chapter 9, we talked all about simple interest. And we talked about that in the context of borrowing. So when you go out and do loans for less than a year, you can find lots of loans made with simple interest. But now when you get out there in this chapter, chapter 10, we're going to talk about investing. Now, this chapter is limited. We're basically limited to talking about investing in bank accounts. So we can invest in a CD that pays quarterly interest or a savings account that pays daily interest. All right, but here's the deal. We are investing. When we go to the bank and put money into the bank, we're actually lending the money to the bank, and the bank is going to pay us interest. All right, but most of the time when you go to the bank, it's not simple interest, it's compound interest. And that's good news. Why? Because compound interest, if you compare the same compound interest to simple interest, compound interest will always pay you more. So that's what we want to do in this example right here. All right, so here's the situation. What is the future value if you invest $5,000 in a bank that pays you 8% compounded quarterly? Now, we're going to see some new terms like future value. Well, let's figure out if we can figure out what future value means. We're investing $5,000 today. Right now, I go into the bank, and right at this exact moment, this present moment right here, I'm saying, hey, bank, here's 5,000 bucks. But I'm looking and I'm saying the contract says 8% compounded quarterly. So now, because the contract is definite in what it's going to give me, I can predict and calculate what the future value will be. Well, why is it future value? Right now, in the present moment, I have 5,000. But when I take this out of the bank in 1 year, that's our example here. We're going to look at an example where we leave it in for 1 year. That 1 year is in the future. So this 5,000 is going to grow to some bigger number in 1 year. So when we're standing here at time 0, when we give this to the bank, we're looking into the future. We want to calculate that amount, the future value. Now check this out. What do they call this? This is the amount we give to the bank. They call it present value. Now, why is it called present value? Because on the day when you're holding it in your hand, you're about to give it to the bank, what's the present value of that $5,000? It's $5,000. So they call whatever you invest at right now, this moment, they call that present value. We're going to go ahead and calculate the future value. Now, there's some other terms. We're going to be given an annual interest rate. A lot of times they call it APR. If you've been to the bank, you've seen that annual percentage rate. They give it as 8%. Now, actually, let's back up here. We are going to have some math formula. So present value, that's how much you put in the bank today, is going to be called PV. This annual interest rate, we're going to call it little I. But we also have another variable that we didn't see in last chapter, number of compounding periods per year. Yeah, we're given quarterly interest, which is good. That's better than one time a year. That means we'll earn more. Quarterly, that's 4 times in a year. Daily, that would be 365, and we'll see an example of that in a couple of videos. We're going to call this, use the letter N to represent number of compounding periods per year. Years, for our example, we're going to have 1 year. We're going to represent this as X. Period rate, what's that? Well, here's the deal. If you're given 8% compounded quarterly, when the bank calculates your quarterly interest, they're sure not going to use the annual rate. That's why I put the word annual here, right? It means for the whole year. So actually, we're going to have to make our first calculation here. Period rate. If you're quoted 8% quarterly, you divide 8% by 4, and that gives you the period rate. That means for the quarter, that's the interest rate you're given. So I'm going to say equals annual interest rate, that's our 8%, divided by number of compounding periods per year. Tab. So in math, it's going to be the little I, the annual interest rate, divided by the N, number of compounding periods. So that's our quarterly rate. When they go to calculate the interest each quarter, It's 2%. Last chapter, chapter 9, we were given an annual rate, and we always use that, right, for simple interest, but not for compound interest. You always have to calculate the period rate. Now here we have 4. If it was 365, we divide it by 365. It was semi-annually. That means 2 times a year. We divide it by 2. All right, so we have our period rate. Our goal is to calculate the future value, FV. Now this is exciting, right? You put this money in the bank and you want to see, hey, how much am I going to have at the end of the year? Now, we're going to start off by building a schedule, quarter 1, quarter 2, quarter 3, quarter 4. And for each line, we'll do it just like the bank does it. There'll be some amount in the account at the beginning. We'll know our period rate. We'll make our interest calculation. And then to get our end amount, we'll take whatever was in at the beginning plus our interest, and that will equal what is in the account at the end of the quarter. And we'll do those calculations for each quarter. And then at the end, we'll have our new total, the amount that will be in our bank account. All right, the start amount, I'm just going to say equals the 5,000. The only time the start amount equals the original present value is right at the beginning of quarter 1. All right, our period rate, tab. Now we calculate our interest. Interest for any given quarter is going to be our period rate times the amount at the start. So it's always period rate times start amount. Okay, so period rate times the start amount. We're going to use our round, and we'll multiply the start amount, that's the amount that was in the beginning of the quarter and sat in there whole time, times our period rate. Now, comma 2, rounding to the penny, and then tab. Wow, so we made $100. There's our start amount. It sat in there the whole period. At the very end, they gave us $100. So that means at the end, we get to add 5,000 plus, that's our start amount, plus the interest they paid us. Now this is different than simple interest, because once they add it into our account, that means this 5,100 becomes the start amount for quarter 2. And that means that when we, and let's do this, equals, and we're just going to go get that. That's right, they added it into the account, and so now at the beginning of the account, it's sitting there. Now it's going to sit there that whole quarter. We're going to have our period rate, tab. Now when we calculate our interest at the end of quarter 2, well, look at that. There's 5,100. That means we're going to get interest on the original 5,000 and the reinvested interest. All right, so equals round. And we're going to say our start amount, principal and reinvested interest, times our period rate, comma 2, tab. That's pretty cool. That $2 extra there is interest earned on interest, right? Because 0.02 times 100 is $2. And that really is the power of compound interest. The longer you let something sit in an account, the more that reinvested interest keeps earning more and more interest. All right, here we're at the end of quarter 2, so we simply add our start amount plus the interest we just earned. Wow, 5,202. So beginning of quarter 3, we say, hey, well, we'll take that amount. Now this sits in there the whole quarter. We get our period rate, and then we calculate our new interest at the end of quarter 3. That means there's the principal in there, plus now there's an accumulated $202 of interest. So we'll get some interest on interest when we multiply the total from the beginning times our period rate. And then we simply add the beginning amount plus, oh, I love adding more and more interest. Look at that. Now I have these decimals showing here, right, just so we can see that the round function is working. We can decrease those if you like. Wow, so now we have $5,306.04. So that ending amount becomes the new beginning amount for quarter 4. We have our period rate. And now we round and make our calculation. I love it. Now we have 5,000. That's the original principal plus $306.04 of interest that we've reinvested. And guess what? We get interest on that when we multiply times our period rate. And finally, our ending amount will be, hey, the amount at the beginning plus all of the latest interest, $5,412.16. Now, we're going to come back here in just a moment. And I'm going to show you how to do some math formulas and some Excel functions that will calculate future value without having to go through this table method. But when you're learning, and in fact, anybody who does this has to understand this fluently, because this is the day-to-day or quarter-to-quarter mechanics of how it's done. Now let's take a look. If we get $5,412.16, 8% compounded quarterly, let's look at a simple interest loan. So in essence, we'll say $5,000, 8% simple interest rate. There'll be one compounding period per year because they just do it at the end of the year, and for 1 year. And let's see how much we get. So I'm going to scroll down here. Simple interest. The present value is $5,000. The annual interest rate is 8%. Number of compounding periods. Well, they don't say it, but there is only one. Right? That's why you're allowed to take the original interest rate and multiply it by the principal, or in our case, present value. Now, so let's make our calculation. Simple interest, it's simply principal times rate, and this is for 1 year times time, right? So we don't really need to put that 1 in there, but we can. And then maturity value, which is really the future value. I'm going to say how much we put in the bank plus the simple interest that they gave us, $5,400. So the future value for simple interest will be that amount. And the future value for compound interest, I'm going to scroll up and get that amount right there, right? Whoops, I clicked on the wrong cell. I meant to click right there. So that future value for simple interest is 5,400. Now, the difference between these, the interest earned on interest. And again, this is just for 1 year. If you leave it in for many, many years, this amount gets larger and larger. Future value for simple interest minus the future value for compound interest, and that gives us the difference. For this 1 year example, that means the interest we earned on interest, $12.16. Now, I want to show you an example here. If I extend this for years and years, here's a chart I made. Okay, these are those same two examples, but instead of leaving it in for just 1 year, we left it in for 2 years. So I called it value in two parallel accounts. That just means $5,000 invested at the beginning, 8%. One was 8% compounded quarterly. One was just 8% simple interest. So after 10 years, look at this. This blue line represents the value in the account for simple interest. So if you have a simple interest account, you're not going to earn as much interest as if you have a compound interest. And notice, as the years go by, the amount. Okay, so right here. So it's about $8,900 or $9,000 right there, right? So after 10 years, you have $9,000. But with the same numbers but compounded quarterly, we have almost $11,000. That's $2,000 more. That means the distance between these tells us all the extra interest we earned on interest. Very important. Simple interest, compound interest. Luckily, most of the investments that we make are done with compound interest. Now I want to go back up here. And I want to go over to some PDF notes. Let me actually right-click, minimize this. And I want to show you a couple things. Now, future value, the longhand way, is that amount we did right there. Enter. Now let's go over to our PDFs. And actually, there's a bunch of notes. I do the same examples we just did in our PDFs. But here's the formula for calculating future value, the math formula. Future value equals present value times, and then in parentheses, 1 plus the period rate. Again, period rate is annual rate divided by number of compounding periods per year. Raised, and in Excel we know caret is raised, I mean, you have an exponent here, and then total number of periods. So years times number of periods per year. So here's all of our variables. The period rate, we just did that, was 2% in the last one. Now total number of periods, we're going to do, for us, it's 4 times 1, right? Because we left it in for 1 year times quarterly. So we're going to raise it to the 4th power. So if we were to do it here on paper, we say the present value, that's the 5,000 bucks we put in. The annual interest rate is 8%. Number of compounding periods per year is 4. Years is just 1. We calculate our period rate, 8% divided by 4. Total number of periods, 4. Here's our formula, 5,000. We plug everything in. 1 plus 8% divided by 4 raised to the 4 times 1. Now, these parentheses have to be there, of course, because you have to do that multiplying before the exponent. Same with all of this. All right, so then we calculate this one step at a time. And we get, oh, 5,412 and 16 cents. I think that's the same way same number we got when we did it longhand. Let's try it. Let's go back over to our Excel spreadsheet. It's up here. All right, you ready? Future value. We're going to do our formula. There it is right there. Equals present value times, and then open parentheses, 1 plus. I have my period rate, so I'm just going to click on it. You should always just do your period rate here. And, oh, we didn't do total number of periods. It's OK. We'll do it in our formula, right? And then caret, that's raised to the, we'll raise to the what? I need years times number of compounding periods, so I'm going to open parentheses. Years times number of compounding periods. You can do that in any order because multiplication is commutative. You can do it 1 times 4 is the same as 4 times 1. All right, and then close parentheses. Ready? Enter. You really? That is so amazing. We don't have to do all of that? That is cool. That's called a lump sum calculation. You put 5,000 bucks in, and at the end you want to know that, meaning you put one lump sum amount in, and you don't put lots of other little amounts in. Just that, boop. And then here's the lump sum at the end that's called the future value. Now let's go back over to our PDFs, and I want to show you some notes on how to do it in Excel. The Excel method, of course, will be the easiest method. Excel function for future value. Now I have a little conversion table. Here's our variable name, future value, present value, period rate, and total periods. Here's our symbols that we use on paper. Future value, present value, and then that's period rate, annual rate divided by number of compounding periods per year. And then here's our total periods, years times number of compounding periods per year. But over in Excel, the Excel function, oh, luckily they'll call the actual name of the function to calculate future value is called FV. When the PV means that's the amount we put in the bank on the day we put our money in the bank. Rate, that is the term Excel uses for period rate. And NPER is number of periods. It means total number of periods. Now here is your notes. So you don't want to forget these as you're learning how to do this. FV, we then put our rate, meaning we click on a cell, comma, we click on the total number of periods, and there's a third argument that we're not going to use in this chapter, skip PMT argument. And the way you skip arguments in Excel functions is you type a comma and leave it blank. And finally, the present value. So this is the $5,000 we put into the bank. We have to put a negative sign in front of it because here's the deal. And I have a little note here. When you go to the bank and you put that $5,000, you are taking the money out of your wallet and putting it into the bank. Now, it's still your money, but for financial calculations, the direction of the cash flow matters. So when you take it out of your wallet and give it to the bank, that's a negative. It means from your point of view, which direction is the cash flowing? From you to the banker. Oh, it went away from me. So that's a minus. It's a minus because it came out of your wallet. Here's period rate. Total number of periods, comma, comma, minus present value. If we were putting in these numbers for this example, it would be 0.02 period rate, total number of periods, comma, comma, and minus 5,000. All right, so these are very good notes when you're making your calculations. And this will work, this function and this calculation will work for the problems we do in section 10.1 and 10.2. Let's go over to Excel. And let's try it. Equals FV tab. Rate, that's our period rate. Comma, NPER, our total number of periods. Now I'm going to force the issue because this is the only example we have that's just for 1 year, or maybe there's 1 or 2 others. I'm going to type years times number of compounding periods per year. So that's our NPER, comma, PMT. We don't have that right here. That's for like a savings plan, which we're not doing in this chapter. And then present value. That's how much comes out of your wallet into the bank. I'm going to type a minus, and then click on this 5,000. And then Control Enter. And there it is, the easiest amongst them all. Now, knowing how to do both of these ways is great because then you can check, right? All right, so in this video, we learned about compound interest and simple interest. We saw how to do an Excel formula using this is actually a very famous function from financial function back from almost 800 years ago. Fibonacci was the first mathematician who came up with time value of money calculations and future value calculations like this. And we saw our Excel function. And don't forget our PDF. There's some good notes for the Excel function and some good notes for the math. All right, next video we'll look at a bunch of calculations. Every single calculation we'll do in the next video is just future value, whether for sections 10.1 or 10.2. All right, see you next video.